Sustainability Roundtable webinar for today. And as you know, we'll be continuing on after the half-hour webinar into the virtual membership meeting. In any case, I'd like to introduce myself, Jeannie Fander at the University of Arizona, with the online education group, which also includes Beth Villar-Williams, Tracy Erbick, Madeline Charney, and Arlene Hopkins. But we're really excited today to have Mike Walker here to present to us. I won't spend too much time with the intro because I know he'll give us a little background on his work. But Mike graduated from the University of Virginia and holds a master's in public administration from Harvard University's Kennedy School. He's the founder of Alter Action Incorporated, a marketing consulting firm specializing in strategies for large-scale human behavior change. And he'll tell us more about his connection to the EPA. So, Mike, go ahead. Thank you so much for being with us.
Great. Thank you, Jeannie. I'm going to see if I can show my slide deck here. All right. Everybody see the Energy Star logo in the upper right?
Yes.
Yep, I can see it.
Looks good.
Great. Okay. So, as Jeannie indicated, I work for a company called Alter Action. Our client, and one of our oldest clients, in fact, is the Energy Star program. And we work on behalf of Energy Star as technical support contractors. We have three areas of expertise that kind of lend themselves nicely to be speaking about IT and energy efficiency. And first and foremost is in this conundrum of large-scale behavior change. So we were actually approached by Energy Star probably 15 years ago with a question. And that question was, hey, we convinced all of the manufacturers of computers in the United States to build into those computers a low-power mode that saves energy. And after congratulating ourselves for a couple of years, we learned that absolutely nobody uses them. So we got involved at that point, and it just so happens that we have background in IT management and IT consulting. I've done a lot of work around efficiency, energy efficiency, and sustainability. So this was a good fit, and we've been working with Energy Star ever since. So I'm going to walk you through a number of very practical things you can do to save energy today with your IT systems. Because this is funded by EPA, the services that I mentioned is free. This webinar is free, obviously. But we do have to be vendor or product or solution neutral, so I can't necessarily endorse any particular vendor's solution. But that's okay. That's not going to limit us too much. So you may be thinking of Energy Star as the organization that puts little icons on energy-efficient air conditioners and refrigerators, and that is correct. A lot of people don't realize that they have a pretty long history with energy-efficient IT as well. In fact, my team worked with Microsoft to improve the features in Windows Vista and 7 that I'm going to be talking about that help you save energy. We've also developed a bunch of ratings for servers, PCs, copiers, printers. I'll talk more about this, but there are a lot of products you probably don't realize for which you have an Energy Star option when you buy them. Even water coolers, that one always strikes people as odd. So what are we going to do today? Well, huge potential energy savings in IT, but the savings remain untapped. And it's worth mentioning why that is, because you may encounter some of these barriers. And that the first is, we call it misaligned incentives. But essentially, all that means is that the person that's paying the energy bill is rarely the person making decisions about how to operate or what IT equipment to purchase. So if you don't incur any of the costs of, for instance, owning a giant four-wheel drive Hummer, if you don't pay for gas, you're probably not going to care too much about the gas mileage. And that, it's a rough analogy to what goes on in IT. Also, IT has competing priorities. So, making sure that systems stay up and operating all the time, that's enormously important and has enormous implications for-profit enterprises for revenue and so forth. So as a result, IT can be very risk-averse. And then last but not least, the expertise around energy efficiency and IT just isn't very widespread. It's not in any IT administrator's training. So, a little bit of this is education as well. But we've basically figured out how to get you past these barriers. So I'm going to talk about 4 specific opportunities in libraries and other organizations. And they're going to go in a rough order of importance in terms of how much energy you can save and kind of how difficult they are. So in other words, the easier ones that can save the most energy first. So let's start with power managing network computers. The analogy here is to lights. You would never walk off and leave your library building looking like this at night. You just wouldn't do that, even if you didn't care about the earth and sustainability. Well, computers should be the same way. We should be powering them down every night. And most people are under the assumption that they are because they may see the screen go dark. But actually, most computers, we know this from surveys, probably 70% do not turn off at night fully. The monitor may turn off, but the computer does not. So we recommend using these sleep features on computers. They're built into the operating system. What they do is they automatically replace an inactive computer, so no keyboard, mouse input, or the processor drops below a certain level, and they automatically put it into a low power mode. And you just need mouse or keyboard input to wake it up. And they're, as I mentioned, built into most operating systems. You may have heard the term standby, hibernate, sleep. They essentially do the same thing. There's some minor technical differences between standby and hibernate that probably aren't worth getting into unless we have a question about it. But here's the thing. These settings are typically not defaulted on. You have to activate them. So that's why, 70% of offices may look like this every night. Actually, that's not really true. What you typically see is instead of these nice desktops glowing, you probably see the monitors dark, but the hard drives and the computer itself, the processor, are still on, and they're still using, somewhere in the neighborhood of 30 watts of power. So let's take a little bit of mystery out of what these settings are. If you've ever ventured into this scary place called the control panel, and I'm using an example from Windows XP because it's been around a long time. Most people probably remember it. But if you went into the control panel and you looked at your power options dialog box, you would see system standby and hibernate. And setting those, either one, will get you a lot of energy savings when the computer goes inactive in the evenings or during meetings or whatnot. So it's definitely something you should be doing, but probably aren't. I'm going to talk about why you'd want to do it, and then I'll talk about a couple of the challenges and how to get past them. So we see energy consumption dropping by $10 to $100 and sometimes more per computer per year. And then you'll also save on cooling loads. So if you're in a climate where you do a lot of air conditioning, the heat generated by active computers raises the cost of cooling buildings, and putting them into sleep mode when they're inactive saves you cooling. And then you may pay peak load demand charges, in which case this will help. And last but not least, of course, we're reducing air pollution and carbon footprint. And I like to mention that if you're a federal agency, you're actually required to use these features. Just to get a perspective on how much these sleep features can save compared to other things in your building. So these are the breakdowns of energy consumption in typical office buildings. And the one on the right is kind of the larger picture, even though it's a smaller pie chart. But, it's basically the energy in a commercial office building is about a third heating, ventilation, and air conditioning, about a third lighting, and then about a third office equipment and other stuff. And of that office equipment and other stuff chunk, computers and monitors and other business equipment are an enormous piece of it. So we'll see buildings drop their total energy consumption by 10% or more by just doing one thing, and that's activating sleep settings on computers. So I mentioned you're probably already doing monitor power management where you see the screen go dark. If you aren't, if you're seeing screensavers, you're wasting energy. this is a no-brainer. It's easy to activate. You won't interfere with any software patching or anything like that. The more challenging setting is computer power management. It saves, as I indicated before, quite a bit of energy. If it's done correctly, you don't have to wait long to wake the machine up. It typically takes a second or two. And this is really what we're after. It's a little more challenging, and I'll get into some of the challenges in a sec, but worth it. So I've talked about several settings, monitors, computers. For optimal savings, we recommend you set that display for the monitor to go to sleep after 5 to 20 minutes of inactivity, and that you put the computer to enter sleep after 30 to 60 minutes. You want to make sure you're looking at the right profile. You want to make sure you're making the changes to the AC or plugged-in profile. A lot of people look at that turn-off hard disk feature and think they're getting a lot out of it. We've never metered a computer that saves more than a watt of power by using that feature, so I would just say ignore it. And obviously, the lower the timeout period, the more you're going to save. So if that machine goes to sleep after 60 minutes, that's way better than 120 minutes, and 30 minutes is better than both. So I mentioned some challenges. The first one is if you have a lot of computers, and if you're operating a computer lab, and a lot of libraries do, it's just prohibitively labor-intensive to walk around to each machine and make those setting changes. So you want a way to do that through the network, and you want a way to control them through the network in case users change them back. And then the bigger problem is you want to make sure you're not interfering with those periodic Windows updates, security patches, antivirus definitions. And here's the good news. There's a ton of solutions out there. And we very rarely find an organization, including libraries, that can't get this done with administrative tools they already own or with free software that's available under a public domain license. So if you wanted to look at the ROI of implementing computer power management, I have labor costs here because it does take a little bit of time to make sure that the solution you pick for your environment is going to deliver the best results. We've estimated that on a per seat or per computer is another way to think about this basis at about $5. And you can pay $0, as I mentioned, for the software to get this done. The most you'll pay is around $15 for commercial solutions that have all sorts of bells and whistles and lots of ways to customize the settings. So call it $20 worst case scenario on costs. And the energy savings we see, again, on average, roughly $30, $40 a year per computer. So, if you figure the average computer has a 3 to 4 year lifespan, and probably longer than that in a library setting, you're talking real money here. So sometimes when I'm doing this presentation in person, somebody stops me and says, why don't we just ask our people to turn off the computer every night? How hard is that? And that may work in some settings, but we find it does not work particularly well in most settings. And the reason for that is we're human. We forget. And you only have to forget a few times a year to overwhelm the amount of savings that you would achieve by turning it off versus putting it in standby. What do I mean by that? Well, standby settings make the computer drop down to about 1 or 2 watts of power consumption. If you turn the machine off, you'd be basically at 1 watt. So you're not going to save anything more by turning off the machine instead of placing it into sleep mode. And people forget. So you're much better off with these settings activated. Quick example, University of Wisconsin, Oshkosh, almost 3,000 computers. They were leaving them on, both the monitors and the computers, after hours. They called us. We have free technical experts that you can chat with that will help you very quickly identify the best solution given the, kind of the personality and features of your computer network. And what they did is they used a native solution in Windows 7. In other words, they bought nothing new. They used tools they already had. We showed them how. They're seeing about $80,000 in savings a year. So let's talk for a minute about the actual equipment that you purchase. And if you're in an organization that has any kind of purchasing department or purchasing criteria, I'd really recommend you add Energy Star to it for just about any type of office equipment. And the reason for that is we have to be reminded sometimes that there are Energy Star options for products you might not think about being Energy Star. And so what you see in this slide on the upper left, for instance, is a computer server. Most data center operators may not even be aware that they have an Energy Star energy efficient option when they purchase these servers. Vending machines. You can request from your vending machine provider that they give you Energy Star compliant vending machines. Most people don't know this. So again, we recommend you bake it into any kind of procurement language that you use in your organization. So I mentioned Energy Star servers. I won't get into the detail here except to say that if you replace an typical older server, 4 years old, with the new Energy Star model, you're going to be able to do more work with that machine and consume half the power. I mentioned vending machines. Typically, they use 7 times the energy of a refrigerator. If you request Energy Star vending machines or retrofit kits in those vending machines from whoever provides the vending services to you, you can save about $150 a year per machine. So let's move to the next topic, computer peripherals and miscellaneous plug load. Boy, we have a lot of this stuff now with all of our electronic gadgets that people carry around. And, if you think about it, and even in a library, you may have things attached to the computer, printers and whatnot, that will use energy. The single best friend that you have in this regard is what we call a smart power strip. And a smart power strip comes in 3 different flavors, if you will. But basically, what it does is it senses when power can be cut off to devices. And I mentioned 3 flavors. The first is a current sensing power strip, and that's what you see here. And the way you can use this is it has a master outlet, and when that outlet, when it senses that the device attached to that outlet turns off, it automatically shuts all of the switched outlets off too. So the way you can use this to really juice your savings is to plug your computer monitors into that master outlet. And when it goes into sleep mode, and again, I recommend 5 to 20 minutes, somewhere in there, it will take out anything that's plugged into the switch outlets, and that could be, lighting, desk lighting, printers, PC speakers, backup drives, space heaters. You really shouldn't have this plugged into a device like this, but, if you do, you don't have to worry about them being on. I don't recommend that you plug the computer itself into the switched outlets, and that's largely because your IT administrators may need to have access to those computers for emergency patching, to make sure, certain maintenance is done, to make sure software is installed correctly. So you don't ever want to unplug a computer, which is essentially what would happen if this was, if the computer is plugged into a switched outlet. Don't go buy these until you talk to your utility. If you buy them at retail, you're looking at spending roughly $30 to $40 per, but utilities often offer incentives to get these a little cheaper. So if your organization has a lot of non-network printers, for instance, a printer in each office or cubicle or so on, or it makes use of standalone copiers, fax machines, scanners, that kind of stuff, I'd really recommend reducing the number of those devices, and we call this printer consolidation. Most organizations have done this already. If you have not, if you still have a lot of those one-off printers sitting around, the savings here can be pretty substantial, and it's not just energy savings. So, what you do here is you replace devices that only 1 or 2 computers can use with devices that get shared across a number of computers, and the ratio we often recommend is around 10 to 1, but of course that's going to vary depending on what business you're in. We recommend that you eliminate the inkjet and other higher cost printers, and that you use multifunction devices. So you save energy here, you reduce hardware and maintenance expenses, and you cut your ink and paper and toner costs as well. So we've done a couple of, actually we did not do this study, but we have seen a couple studies that show somewhere in the neighborhood of 30 to 60% of whatever you're spending on printing total being saved simply by consolidating printers. So that brings me to, last but not least, data centers. And you as a librarian may have a data center, you may not. You may just have a server room. You may just have a server closet. If you have any of those things, this does apply to you. And first, it's important to understand why it is that data centers are such energy hogs, and they are energy hogs. We estimate that of the total amount of electricity generated in the United States, anywhere between 2 and 3% of that goes to power data centers. And if you think about it, everything we do on our smartphones, everything we do on our computer, just about has a data center somewhere in the background. So just to give you a quick example of why data centers use so much energy, the devices themselves use a lot of energy, and they tend to be very densely packed. So in this example, if you're familiar with Star Wars, Industrial Light and Magic did the special effects for those movies, at least the early ones. So they deployed all of these servers in a rack, and we ran some calculations and figured out that just one rack uses 28 kilowatts of power and requires 8 tons of cooling. To put that in perspective, that's about the same as what two average-sized homes would need to cool off, in the summer, central air. And we figured that each rack is the equivalent of roughly the heat generated by 4 Weber gas grills. So, and this is just waste heat that's being generated by computer processors. So we figure each rack could cook roughly 300 hamburgers an hour. That's how much heat is being generated. And if you're generating that much heat, you have to get rid of it or the equipment will fry. So this equipment requires a lot of cooling. How do you save energy in data centers and server closets and so forth? We recommend first you focus on the IT equipment itself. Then you look at how air flows around the server room or data center. You want cold air from either outdoors or your AC units to reach the fronts of servers as efficiently as possible. And servers draw air into the front and exhaust hot air out of the back. So you want to make sure that hot air doesn't mix with your cold air and gets back to the AC unit return. And then in addition to airflow, which can also have to do with fans and so forth, HVAC adjustment. So we used to think that it was necessary to keep data centers really cold. For example, that is no longer true. The equipment is quite heat tolerant. We also used to think that server equipment needed to operate in pretty narrow humidity ranges. If you had too much humidity, you risk condensation on the equipment, and condensation can conduct electricity and burn out components. If it's too dry, you worry about static electric discharges. So we now know that the equipment is much more tolerant, so you don't need to control humidity as much. You don't need to control the temperatures as much. And I realize this is not enough time to really do the data center justice. If you're interested in data centers and server rooms, I want to point out a couple of good resources. One is at the EnergyStar.gov Low Carbon IT website, you can read what we've tried to make non-technical descriptions about how you save energy in data centers. And we've gone over kind of the 12 most common energy efficient measures. And we give you impartial information about what they might cost, savings, even implementation considerations. And the goal is that, you would look at this resource or you would attend one of the Energy Star webinars, and you can find information about that on the site as well. And perhaps I'll talk to American Library Association about doing another webinar on that topic. But at any rate, you can learn enough in an hour or so to be able to walk through a data center and begin to identify opportunities and begin to have conversations with the data center managers and the IT managers about things you might do to save energy. So I just have a couple more minutes, so I want to leave you with some practical advice on how to proceed or how not to proceed. So I'm going to just acknowledge this up front, a lot of IT energy efficiency projects do kind of run off the tracks or run out of steam. And the reason for that is you kind of have a mismatch of information. You, the librarian or the business manager or maybe a facilities manager or whatnot, without information about how IT networks are managed, are kind of at an informational disadvantage. So, what we'll hear a lot is that somebody will attend a webinar like this and they'll approach their IT person and the conversation goes something like this. Hey, I heard this webinar, great opportunities to save some energy, green up our operations, and the response from IT might be, hey, that sounds like a good idea, but. And then the but is followed by a string of technical talk, and without tech training, it's incomprehensible. And then the project sort of dies a premature death. So you kind of need an IT expert on your side, and you have one. So we provide vendor-neutral technical advisors that can hop on a call with you and your IT colleagues, and we can help you, and more importantly, help your IT person really quickly get to the bottom of what needs to be done. And we typically will do these calls, and in 30 minutes or so, we get from sort of this abstract idea about what we could do to save energy to very concrete implementation steps. And again, this is a free service. So 4 steps for getting people on board with projects such as the ones I talked. First is look for opportunities. So look at the computers, look at the current settings. If you need help estimating how much you might save, we've got help for you. You can find all sorts of savings information, including a savings calculator for computer power management at the Energy Star website. You can talk to your utility about rebates and other benefits that might be available to you for taking energy efficiency measures. And talk about the side benefits. So it's not just energy savings. Most of the things that we recommend you do to save energy and the ones that you've kind of done a quick overview of here have other benefits. Increased reliability, increased security, and so forth. Remember that you have a technical person on your team. Use it. And share opportunities, build a coalition, share with friends in administration, finance, facilities, et cetera, et cetera.
And Mike, we do have a couple of questions that came in through the chat. One that just came in and a few before. One question was, is it true that workstations use 30 watts per hour if the sleep mode's not activated?
Well, so watts are a measure of just power consumed at a moment in time. So 30 watts, they do tend to use about 30 watts of power, and it doesn't matter. The temporal dynamic is watt hours. So watt hours would measure how much energy is consumed over a period of time. But if you plugged in the meter to a computer, it would be sitting there burning, anywhere from 30 to 50 watts of power for a desktop. So you can compare that to our old incandescent light bulbs that hopefully everybody got rid of, but they're in the 40 to 60 watt range. So it's equivalent to leaving a light bulb on, burning all the time.
All right.
Laptops do use less electricity. They can be in the 10 to 25 watt range, but still you do save a nice chunk of energy. It might be on the lower end of that savings spectrum that I showed you, but still worth doing this on laptops as well. And by the way, those two figures don't count monitors. So if you don't have monitors automatically sleeping, you can add another 10, 20, 30 watts, depending on the monitor, to that figure.
All right. Well, Mike, we're out of time to address the questions, but I just want to let a couple of people know who have put in questions that we will get those to Mike and we will send them out to everybody on the participant list via email so that you can get the information about the recycling IT and the question about the site energy production and solar power. So we make sure and address everything. And we appreciate your time, Mike, and we appreciate everybody's participation. And I'm going to turn it over, I think, to our other panelists. I'm not sure if Madeline's going to take over to lead the virtual meeting. So if everybody can stay, that would be wonderful. We appreciate it. And if you have some more questions for Mike, you can see his contact information up on the screen, and also feel free to send it in via chat if you're still on here, and we'll make sure and get it to him.